All right. Hello, folks. I am back. Robert Hafner, author of Terraform in Depth, and this session is all about answering your questions. What do you want to know about Terraform, Open Tofu, infrastructure as code, my favorite recipes? Anything you want, that's what this talk is for. So please hit those Q&As. Ask away.
All right, so we have a bunch in Q&A already. So let me just get started here. So how can I specify the order of resource deletion in Terraform OpenTofu? I face issues destroying cloud resources tied to a load balancer.
Yeah, so what you need to do is you need to use the depends on. The depends on creates relationships between different resources, and that works in multiple directions. When you first create everything, it creates it in that order that you've defined things. And when you delete things, it goes in the reverse order, essentially, because behind the scenes, everything in Terraform is a graph. You have nodes connected to other things, and they're directional. So you can specify any of those dependencies implicitly by just having resources refer to things directly. But if you're seeing that things are getting destroyed before other things and there is no implicit relationship, create that explicit relationship with the depends on meta parameter. And then that should solve that problem for you.
Cool, thank you. I guess one that just popped in. We love tofu. How important is maintaining parity with Terraform to the project?
You know, well, to the Open Tofu project itself, I will say I'm not on the Open Tofu project, so I don't want to speak for them. They seem to have done a very good job of it, though, and it's interesting to me that I initially thought of Open Tofu as a superset. It's got everything as tofu, and then of Terraform, and then additional stuff. But even stuff that's come up in Tofu first, HashiCorp has turned around and adopted. In general, I'm assuming because Tofu is making good decisions. And so I feel like parity has been important. I am not a person on the I am not the person on that team though, so I don't want to like misspeak on behalf of that group. I do expect over time that there will be more changes in place, but for now, it's been pretty easy for me to have code that works for both.
Cool, thank you. So up next is how do you handle necessary pre-existing infrastructure, for examples, owning a domain, for example, owning a domain so you can do automatic certificate validation with ACM or Route 53.
I mean, for existing stuff that has already been created by another system or platform, I mean, that's what data sources are for. You just use those to pull them in. If you work at a company where like you have one team that manages the networking and then you're building on top of that, you might want to create a module specifically for pulling in their network resources. I think domains themselves are a very specific thing because you generally purchase those and you want to make sure nobody like accidentally forgets or removes those. That tends to be a little bit more of a human process. But like actually managing the routes and stuff, you should be able to do in Terraform without issue. But yeah, if you need to pull in external resources, that's exactly what data sources are for. And there's all sorts of techniques you can use for doing that too. You can use tagging, for example, in AWS. Going back to that network example, if you have like public, private, protected networks, if they have their own tags, you can use tags to pull them in. Otherwise, you can use things like variables to just pull in like the ARN for what you're looking for.
All right. Um, so another question is, what are some tips to increasing the efficiency and speed of Terraform OpenTofu plan and apply?
Oh, that's a fun one. There's a lot that goes in there, and there's stuff you can do, there's stuff you can't do. Now, you might be tempted to do something like raise the amount of parallel requests that occur, but then you might end up hitting rate limits. Um, the reality is that what you're asking is really, really hard. It's something that the engineers themselves they work on, but there's also just a lot of dependencies outside of that. I think depending on your specific projects, you could aim for having smaller and smaller projects, but then that also can raise complexity in other areas. The other thing, though, smaller changes are easier to apply. I've seen teams where they'll go and they'll have like one big apply like every other Thursday. I've seen teams that have like three applies every day. I highly recommend the second option. Deploy small changes, deploy them quickly, deploy them as you need, and then you shouldn't have to wait as long for things to occur.
Okay. And there's another one here. Is there any good way in Terraform to represent a recursive relationship between things? For example, a module that accepts a map of names for spaceless spaces to space configurations, which themselves have spaces as subproperties. Sorry.
Yeah, so the problem that you can end up here is that, Terraform underneath the hood is building a graph representation, and it's building an acyclic graph. So in computer science terms, this is all fancy and there's like math that goes behind it and stuff. But essentially what they're saying is you have one node that connects to another node and there's a direction. If your nodes have a circle in them, that's called a secular graph. And secular graphs are incredibly hard to deal with because the question is, what do you create first? If everything's dependent on everything else, what do you create first? How do you get into that? And so this is one of the hardest problems that you can find. But in most cases, I find there's really kind of two ways to approach it. One is to try to decouple it from being a direct relationship. So let me give an example. Let's say you have one API that depends on another API that depends on the first API. You've got APIs that depend back and forth. If you don't actually need that dependency at launch, but you need it to run, you can pass the URL to each one as a parameter. It'll pick up that URL and it'll do stuff, but it won't be an actual real dependency. In other words, you kind of go up the chain a little bit to see if you can get that extra information somewhere out of the resource itself. Now, this does mean one resource might launch and then not be able to function until the other one comes up, but you end up with that problem anyways with that circular dependency where you just can't launch at all. My second suggestion is to just re-architect a bit, to just remove the need for that circular dependency, because circular dependencies end up kind of creating their own code smell. They are harder to maintain, they present their own problems. So I'd recommend just looking at your architecture and see why you need that. And if possible, remove the need for that. Otherwise, I would recommend trying to go up a level to find the same data and shove that in as your parameters and attributes to your resources without pulling it directly from the other resource. So there technically isn't a dependency in the graph. It's more of there's a dependency in the services when they're up and running.
Thank you. Okay, so we've got a ton of questions and more coming in. So how do you implement the need to run specific types of plan, apply like a replace, attained, or targeted?
How do you implement the need to run specific types of plans? I'm not entirely sure I actually understand the question, if I'm going to be honest. This sounds like it's a deployment plan. Like, are we building out like GitHub Actions or using something like Spacelift? But I'm going to be honest, I'm going to need a little bit more clarity. Sorry, Jeff. I'm just not quite understanding what the question is here.
Jeff, while you put that in or put it in chat, and we'll get to that. We'll go with this one. Can you please suggest some use cases for using Terraform in legacy data centers using hypervisors?
That's a very interesting one. And I'm going to be honest, I am a big fan of using the right tool for the job. I don't necessarily think that just because I wrote a Terraform book that I should write everything in Terraform. In fact, there's a section in my book where I'm like, don't use Terraform for this. And I'll give you some quick answers to that. Like, I never use Terraform to deploy to a Kubernetes cluster. Now, using Terraform to deploy a Kubernetes cluster makes a ton of sense. It's great to do. And this might be a use case where you want to use Terraform to launch something on top of hypervisors. It's going to depend on your hypervisors, though. Do they have an API? Are you talking like vSphere? Are you talking like OpenStack? You can treat those almost like on-prem clouds. But if you're really talking about like doing low-level deployments where you are just like logging into individual hardware and then like setting up hypervisors and stuff like that, then I don't necessarily think Terraform actually is the tool for the job for that. That's the kind of area where something like Ansible is probably going to perform a little bit better. And I mean, in theory, you still can go and you can set up a bunch of stuff, SSH connections in and all of that. But again, I'm a big fan of using the tool for the job. Terraform is fantastic, especially when it comes to cloud resources. And again, that includes private cloud, like OpenStack, vSphere, if you're stuck using vSphere, and things like that are easy to manage with Terraform. But if you're getting into that like low level, I'm actually messing with hardware, then I don't necessarily think that Terraform is the appropriate tool.
Cool. And Jeff wrote, the question is, yes, is for implementation in GitLab pipeline or GitHub Actions. So you inferred it correctly. So he said, we only have FMT, validate, plan, and apply in our pipelines, but we often get engineers asking to do custom actions.
I'm curious what the custom action would be, though. I mean, what you probably need is an escape route to do custom actions. I'm assuming this would be things like running an import, although these days imports and moves really should be done using the import and moved blocks that have been added. There's some state manipulation stuff that might come in, but in general, the way most systems work is like if you're using something like a spacelift or a scalar and zero or something similar, they'll normally have a place where you can kind of type commands and allow them to run from inside of that system. Otherwise, if you're using like GitHub, you could create like a workflow dispatch that allows you to bring inputs in and include the command you want to run as one of the inputs. But you should also be aware that that could present its own security issues as well, where if people can run arbitrary commands after authenticating as your user, that there's stuff that they can do that you might not like. In this case, if it's really ad hoc and it's really custom, you might just end up doing it from a laptop, but still connecting back to that back end. Or it might be that you've just grown beyond being able to use GitHub Actions or GitLab pipelines, and you need a more formal CD tool. And I will say, like, I'm a big advocate of CI and CD being separate from each other. I think GitHub Actions has done a fantastic job of being like a fantastic CI tool, but I find that most repository-based things and CI things, they're really based around your source code and your artifacts, and you can finagle them into doing deployments, but I find that deployment tools are better at deployment than, integration tools. And so if you are finding the point where there's a lot of complicated things that are coming up and your pipelines aren't as easy to manage as you want, it might be time to look into one of those more advanced tools like a Taco or something similar. And my preferences are, if you do look at something like that, consider like Spacelift or M0 or something where it doesn't just Terraform. I will say I do have a bias towards the things that aren't just pure Terraform, but allow things like Kubernetes and Helm chart deployments and things, since I think a system has use of that.
Cool. One other question here. You emphasize the importance of backend state management in your book. How do you recommend teams handle state effectively, especially as they scale their infra and grow their teams?
Yeah, so I think this is incredibly important because this is one of the most dangerous things I see when I talk to people. I see people putting their state in S3 buckets that are in the same accounts that they're managing. I see people, giving out way too many permissions to the state system. I see people not using proper backups at all for state. And, it's very simple to accidentally delete an S3 bucket, lose your state, and then all of a sudden, like in some cases, the easiest way to deal with it is to just relaunch everything to begin with. There are a lot of options out there for state. You can go that S3 Dynamo route. If you do, make sure you have backups, make sure you're doing segmentation. So different teams have their own either buckets or at the very least folders in those buckets. Try to isolate things so that way teams aren't just diving into state and pulling out sensitive data. And of course, make sure you have backups. Of course, there are systems like GitLab, which I believe includes state by default. And then, of course, other vendors, which also have great state management tools. You could also pull some open source stuff out. I do go into a lot of detail in my book, but again, the biggest things are access control, isolation from your other managed resources, because if you have everything in the same account, it's just very easy to mess that up. And then make sure your access control for that state is locked down. And there are just so many places you can shove state these days, from like Artifactory to like open source projects. I think it's going to be dependent on your team, their needs. their size, and how they scale out. Something where you've got thousands of users for Terraform, like SSO is going to be critical. The ability to audit that is going to be much more tough, and you might end up having to pay for a vendor. If it's something where you're a startup with 8 people, just create a couple of extra accounts. You have your AWS infrastructure S3 bucket account, your backup account, and then use things like OIDC so people aren't directly logging in and there aren't credentials to share when they access their resources.
All right. Another one here regarding IaC pipelines. What is the best practice with cloud accounts for different environments? Using a single pipeline split with environments, so dev, staging, prep, prod, or create a repo or pipeline per environment?
So I will say that there's kind of a mix here. I'm a big fan of TerraGrunt and systems like it. I believe that your infrastructure module, so let's say your root module or top level module, and I wish we would all just kind of pick a name for that and call it that everywhere, but the thing that actually launches your infrastructure. I believe that should be a thing that should be versioned and deployable in each of those versions. If you create that top level module and then you put your environments inside of it as TF files, var files, you end up in a situation where every time you add a feature, you either have to do a deployment to every one of your environments, which kind of defeats the point, or your GitHub, your Git repository is no longer a source of truth for your infrastructure, which to me also defeats the point. So I typically have one repo for the actual project, that's the module, and then I have another repo with all of my TerraGrunt configurations, a folder for each environment, and then inside of that I reference the module and then call it in with the appropriate inputs. You don't actually have to use TerraGrunt to do that. You can also just have a repo that has all of your environments in different folders with a main.tf that pulls that module in and essentially accomplishes the same thing. Or if you're using something like, one of the vendors, a lot of those support tags for deploying. And so you just kind of tag the thing and then you can update your individual workspaces. But the one thing that I cannot stress enough is when you merge your actual project and the environments themselves into a single repository, you're locking yourself up into a situation where deploying to multiple places is basically required, or you're moving away from that GitOps flow where Git should be your source of truth for your infrastructure. And I find that to be an area where things break for people. But I do recommend, if you're trying to do the GitHub-based deployments, just use TerraGrunt. You might think it's really complicated and stuff, and maybe the docs could be a little better in some areas to just bootstrap you and get you started. But it's actually really, really simple to use.
Yeah. It's funny, Jesse said TerraGrunt is great, but it's rather difficult to explain why it is so great. So I like that.
Yeah, it is fantastic, and it allows you to have control over each of your environments independently, and I think that's just incredibly important for something like this.
So one of the other questions that I'm seeing here is, what is your opinion on TFR files for shareability with other dev teams?
So I'm trying to think here. I tend to use TFR files for development to make it very easy to do local development. I pull something down, I've got the TFR files, I maybe tweak a couple of things, and then I push it back up. Because I tend to use TerraGrunt for a lot of deployments, I don't really need a TFR files because it just kind of goes into the TerraGrunt config. But if I was using that other methodology, I'm going to be honest, I don't really like using TFR files all that much. I end up just using kind of whatever the platform is, whether that's environment variables or hard-coded stuff. Actually, I tend not to like environment variables for anything other than secrets too, if I'm being perfectly honest. Obviously, you don't want your secrets embedded in code, but I'm either dumping my variables directly in a main.tf inside of a module with that one folder per environment methodology I said, or I'm dumping them in TerraGrunt configurations instead. So Yeah, that's my thought on that. And then, for secrets and credentials, if you can, don't use secrets and credentials. Like use OpenID Connect. In a lot of cases, you can actually get away and not even need to store, like, if you're storing AWS credentials anywhere, like you're doing it wrong. Like OpenID Connect anywhere you possibly can. Remove the secrets. But outside of that, yeah, I just tend to avoid the TFR files simply because I'm using either that module method or I'm using the Terragrunt method.
Okay, so there was another question about the book. The target audience for Terraform in depth. Could a product manager get something out of it? What about junior engineers and Terraform experts?
So I tried to design the book so that a lot of people could get things out of it. Not as sure about product managers, but if you're a developer who's going to be using like infrastructure and code, I start the like first third of the book is just learning Terraform. But I've heard from people that there are tidbits in there that even experts were like surprised about and learned about. So, if you already know Terraform, you can probably skim the first third of the book. The next third of the book is all about Terraform with teams and safety nets and testing. How do you actually use Terraform in production? And then the final third of the book is just really advanced use cases, things like building your own module, programmatically integrating Terraform or Tofu. And actually, I specifically focus on Tofu for that one since it's actually open source still. People who are building new things should probably use that instead. And then I use the talk a little bit about other just advanced topics that you probably won't, encounter every day, but that will be useful for you to have in your tool belt. So I really do think that every Terraform person out there, whether they've been, programming with Terraform for years or just heard about it yesterday, can probably get something good out of the book. I think the first third of the book, though, somebody who's an expert is probably going to skim a bit more.
All right, thank you. So another question is, can you use multiple workspaces for a single project, and what is best practice for structuring repositories?
All right, first, before we get into this, I need to talk about the word workspace in Terraform. I have problems with workspaces in Terraform because they mean different things. Initially when Terraform came out, there's the Terraform workspace command, all of that, and it's basically just another like hidden folder for storing state files. Okay, cool. You switch between one and the other, you're moving around, you have a nice little like variable that gets set so you can like automatically load different things depending on what your workspace is. Very useful for running things locally, but I don't find it very useful in deployment because most of my deployment is through CI/CD tools, and therefore, the workspace paradigm doesn't really help with anything. But then HashiCorp came in and did what I think was probably one of the like least user-friendly things they possibly could, and they overloaded workspaces to mean something completely different when you're using Terraform Cloud, HashiCorp Platform, whatever. And not only did they make it mean something very different, but they made it so when you configured the back end that actually talks to the cloud, the Terraform workspace command acts completely different. It is 100% different. Instead of it being like a different version of your same project, you're not talking to the workspaces up on HashiCorp Cloud, which could be completely different Terraform projects, variables, all of that all together. And so I'm going to be honest, I think that you should just avoid workspaces altogether unless you're explicitly like a HashiCorp Cloud user and you're using that workspace feature. But if you're using that older style of workspaces, you're not using the cloud block, but you're just trying to manage state files locally, just don't use workspaces. There's no real benefit to using them. They just get in the way. Instead, what you should do is what we were talking about before, where you either have a different folder for each of your environments, a different configuration for each of your environments in whatever your cloud platform is, or your deployment platform is, or you use something like Terragrunt to organize your environments. But I would not use the local workspace features personally. I've seen it cause too many issues, and there's just so much confusion between that and the Terraform HashiCorp workspaces that are now kind of commingled in. It's one of my big hot takes of the day.
Good one, though. So the other question is, what are your thoughts on decomposing teraliths?
Yeah, so this is again, it's like it really depends on the project. Like if your project is small enough where you can run a Terraform init, run a plan, run your updates, and they all take a couple of minutes, then I don't really see a lot of benefit. But I do see a lot of benefit in having the teralith. Like if you can download a project's module, click a button and run it, that's great. Like, it makes development super easier. If you're breaking it up into multiple repositories, now you have different steps. You have to like run this repo, then you have to run this and this, all to get a development environment. At the same time, though, on the other side of things, if your project is so big that running your update actually takes like 30 minutes, not, discounting like RDS and things like that, where you just don't have any choice, then maybe it is time to look at re-architecting. I'm going to pull out Conway's Law on this one. Conway's Law is that teams and software architecture tends to follow the same structure as the organization. In other words, if you've just got one team and they're just building a bunch of stuff, chances are you're going to have a lot more terralists. Whereas if you've got a company where there's like a networking team and a database team and an API team and all of that, then you're going to see each of those teams kind of creating Terraform to manage their own systems and platforms, and you're focused more on the integration side. And so, this might be a little bit of a cop-out, but the answer is it grossly depends on what your team and your structure is. But what you should be focused on is what makes it easiest for your developers to work. That's the focus. And so if you work at a small company and it's easier to have a Terralith and that lets you move fast, then great. If you're working at a big company and your Terralith is slowing you down, then break it up.
All right. Thank you. Next up, do you recommend locking down state files to the CI/CD tools or allowing devs to access them?
I think that they should be locked down by default with an escape route to access them if needed. So like, throw them in your back end, make it so only CI/CD tools can really access them, but give developers a way to access them that alerts your security team when they're accessed, or alerts everybody on the team when they're accessed. State files have to be considered secure. They have to be kept safe. And so I would say, like, you're going to need to have access for some things. Something might break. Something might cause a need to debug. But I will say, over the years, the need to access state files has definitely gone down over time. Things like the import blocks, the moved blocks, they make it so you can put changes for state in your code itself and just push it and allow your own CI/CD tools to do it. So yeah, they're very dangerous things to access. You should have to jump through some hoops to access it. That creates some level of audit trail. That's my thought on these. And for the taint untaint, like, that's something that you can easily create like a pipeline for. You can have like a GitHub action thing where you just have a resource name as the input. You go there, the workflow dispatch, you type in the resource name, click a button, you've tainted it.
Cool. So we have one more question here. I think that might be all we have time for. But thank you. We have tons of questions, so we'll try to get to them after the fact. How do you decide when Terraform code complexity is just too great and you have to rethink about your code? For example, if you have variables to toggle things on and off, complex for loops, nested functions, performing string manipulation, etc.
So I try to start from the other side first, and I try not to overdevelop the modules. One of the things I've seen people do is, like, they say, like, okay, I need to go write a module for EFS. Now I'm going to go and support every feature of EFS. Focus on what you actually need to support first. Think about what's coming down the pipeline, but don't implement it until you actually need it. When it comes to things like complex loops, like, sometimes you need those, but those should mostly be about data transformations. They really shouldn't be about creating a ton of infrastructure. Try to move that higher up into your code so you can eliminate some of those loops altogether if possible. Use composition when you can, as opposed to nesting. Try to avoid deeply nested modules altogether. If you have more than 2 levels of nesting, there's probably some re-architecturing that needs to be considered. But again, it kind of goes back to how easy is it for the users to actually use this module to make changes. That's when I tend to trigger refactor. refactoring, ignoring things like security issues or new providers that come out. If it's hard for people to actually accomplish what they do, if it's hard to debug, and if you're getting errors and you're just struggling to do, then your stuff's probably too complex. Have it be driven by your actual needs and use cases.
All right. Thank you so much. We only have 11 seconds left, but thank you so much for the answers, and thank you all for the questions.
Yep. Feel free to hit me up on LinkedIn, Blue Sky. I hang out in Reddit too sometimes if we didn't get to your question. And thank you for coming.
Thank you so much.